Hi students, welcome to Subtracting Rational Numbers 3.3. Now I had mentioned that in 3.2 adding rational numbers, particularly with fractions, not so much with decimals, but with fractions is an area that students sometimes struggle with in grade 9, but it's very important in grade 10. Well, the same sort of principle applies to subtracting fractions. The process for completing those questions is very similar to adding. So essentially, if you can add fractions, you can subtract fractions as well. It's a very similar process, but it does require a little practice if it's something that you didn't do a whole lot in elementary. So let's look at subtracting rational numbers. Now, how do we subtract a negative number? Let's come to the solution. Let's come at the solution to 4 minus a negative 3 using BEDMAS. If we look at this question, we've got 4 minus, but we've also got a negative 3 in brackets. Well, if there's a minus touching a bracket, then it's really just multiplying by negative 1. So if we're doing BEDMAS, we can do multiplication first, and the multiplication is right here. And we can just change those negative signs to help us make it a little clearer. All right? So if we multiply a negative by a negative, in this case it becomes a positive. So whenever I see a negative number hitting a bracket and then another negative number right away with nothing else in between them but the bracket, I just make this plus plus. Just like that. So it's really 4 minus a negative 3 is really just kind of like a double negative, right? And a double negative is a positive. So if I put a plus sign for both of those negative signs, the question really just becomes 4 plus 3 is 7. So what we're really doing is we're multiplying out the negative 1, because if we look at a negative 3, okay, we don't even need another number here. This is really the same as negative 1 times negative 3. And we know negative 1 times a negative times a negative is going to be a positive. So it's really just turning it into a positive 3, which is what we did over here. A negative 3 just turns into a positive 3. So it became 4 plus 3. So that's what we're doing, and that's what we should be kind of thinking in our head. But in reality, when you see a negative bracket negative, okay, you just do that right away. Okay? And after a while, you won't even think about it. All right? So find each of the following differences. Difference is just subtract, right? When you see the word difference, it's just subtraction. By first performing multiplication of negative 1, really. Show 2 lines of work, determine if your answer is reasonable. So in this case, it's really like 10 minus 1 times negative 5, right? Negative 1 times negative 5 equals a positive 5. Negative times a negative is a positive equals 15. And let's just see if our answer is reasonable. We started at 10, and we subtract, which normally means we're going left. But if we're subtracting a negative, it changes directions, right? Just think of it as, in this case, 2 wrongs do make a right. 2 negatives do make a positive. So instead of just going subtract, we have to subtract and then subtract the other way. So negative equals positive, so we end up moving this way on the number line. Okay, so 10 plus 5, we start at 10, and then we're going to jump 5 more positive, it's 15. So our number does make sense there. Okay, this time we've got a negative number out front, and then minus a negative 16. So let's just write that as minus 1 times negative 16. Okay, because that negative is really just negative 1. So we end up with a negative 6 still here, but a negative 1 times a negative 16 becomes a positive 16. So now, what we're looking at, my equal signs there. So now what we're looking at is we're starting at a negative, okay, so if this is your number line, okay, these are the negatives and these are the positives. We're starting at a negative 6 here, but then we're making 16 jumps towards the positive side, which is to the right side. So negative 6, and then if we jump 6 forward, we're going to be at 0, and then we got to jump 10 more times to get there. So a negative 6 plus a positive 16, we end up at positive 10. Next one is very similar to that, it's just different numbers. Negative 20 minus a negative 11 is really minus 1 times negative 11. All right, so negative 20 stays. Okay, and negative 1 times negative 11 really is just plus 11. So we start in the negatives down here in negative 20, and we got to make 11 jumps toward the 0. But we're not going to make it to the 0 because it's less than 20, right? So we're going to get less negative. We're moving toward the right. And how many jumps to the right does 11 take us from negative 20? It takes us to a negative 9. We don't make our way out of the negatives. So do you have any other strategy? You can fill this in yourself. But, my biggest strategy is when you see a negative and then a negative number, just make it plus. That looks like TT, doesn't it? Make that a plus. That's what I do. And there's other strategies, but I'll kind of leave it to you to see what works best for you. Just make sure you're getting the right answer and that you understand what's happening. So it says simplify each of the following expressions. Okay, so I'm just going to tackle these the way I would. We got 5 plus a negative 7 plus a 4. So when I see a plus and negative, my natural reaction, it doesn't have to be yours, but my natural reaction is just to say those together just basically equals subtract. Okay? So 5 minus 7 plus 4. Work left to right. 5 minus 7 is negative 2. Right? 5, and then we got to jump 7 toward the negative, which takes us past 0 into the negatives, and then plus 4. Now we go the other way, right? So we're starting at negative 2, and then we got to add 4, so we got to jump past the 0 to positive 2. Okay, this one's just got more negative signs. This is all about signs. It's all about what you do with the signs. And in this case, the signs are negative. Those are the ones that really matter to us. So we've got negative 8, okay? Now we've got a minus. So that's just plus, right? Minus a minus is just a plus. So that's plus 11, okay? Now plus negative 4, I usually just write that as minus 4. And then minus 6, well, there's nothing in the bracket, so it's really just minus 6. So I just wrote this out in a way that makes more sense to me. I start out at negative 8, and then I got to jump 11 toward the positive, so I go past 0. And if I start at negative 8 and make my way 11 steps toward the right, I'm going to end up at positive 3, right? I jump right past 0. Minus 4, minus 6. Okay, now I'm at 3, so I'm on the positive side. Okay, so I'm at 3, I'm over here, and then I've got to subtract 4, so I'm going toward the negative. So if I subtract 4, I get to the 0, and I actually have one more. So 3 minus 4 takes me down to negative 1. Now I'm negative 1 minus 6, so I'm over here, and I'm subtracting, so I have to get even more negative, right? So I have to jump 6 more this way, which takes me all the way down to minus 7 or negative 7. So it's kind of up to you to use the strategy that you want, but that's what I do in my head when I see numbers and signs that look like that. So subtracting rational numbers with fractions is, again, the sticky point for a lot of grade 9 students, so we just got to work at it. To subtract two rational numbers, we use a strategy similar as that for subtracting integers. So from 5 minus a negative 3, we can multiply out the negative 1, right? So 5 minus 1 times negative 3, really, negative 1 times negative 3 is just a positive 3. So that equals 8. Okay? And it would be the exact same thing if you used my strategy, which is 5 minus negative 3. You're still doing the same thing. It just kind of looks a little different. I just turned both of those into plus. I usually do it down here. But I don't want you to confuse what the question originally was. So I'll just keep that written as 5 minus a negative 3. So to me, that just means plus plus, and 5 plus 3 is 8. So it doesn't really matter which way you do it. You're doing the same thing. You're just making it look a little bit different. Whichever one makes more sense to you is fine to use. So you see that we started at 5 and we added 3. 1, 2, 3 big jumps. We end up at 8. For 1.5 minus 1.25, you can do the same thing. You can multiply out the negative number. So if we've got 1.5, okay, minus a negative 1/4, okay, that's the same thing as putting a 1 there. So that would be 1.5, okay. Negative 1 times negative quarter, a negative times a negative is going to be a positive 1/4. Okay. Now, they didn't specifically show it in this step, but because we are adding fractions, we need a common denominator. So we change this mixed number, remember times and plus, so 2 times 1 is 2 plus 1. So that's really 3 over 2 plus 1 over 4. These need to be the same. Okay, these need to be the same. So how do I turn a 2 into a 4? I have to multiply by 2. And whatever I do to the bottom, I have to do to the top. So this turns into 6, 3 times 2 over 4 plus 1 over 4 equals, remember to write the denominator, don't add these denominators, add the numerators, 7 over 4. 7 over 4. How many times does 4 fit into 7 evenly? Just once. And there's 3 left over, so it's 1 3/4. Okay, so if we look at the answer here, we got to 1 3/4. They didn't show all this math, but I think it's important for you to understand how they jumped from 1.5 to 1 3/4. They didn't really just do it in their head. I think they had to solve this by turning it into a common denominator and then turning a mixed number or an improper fraction into a mixed number. So that's important to me. I think that you understand how they got from -1.5 to 1 3/4. So let's look at a couple questions with fractions, and let's just apply what we know about common denominators. So I'm just going to write that up here, common denominators. Okay, so that we don't forget. It's the same as addition. The only difference is that when we get to the point where we have common denominators, we just subtract instead of adding. We subtract the tops. Okay, that's the only difference. All right, let's do this one the easy way. Let's look at the denominators. I've got a 6 and I've got a 3. Is there a way that I can turn the smaller number into the bigger number with multiplication? In this case, I can. Okay, so that's going to help us with that shortcut. How do I turn a 3 into a 6 using multiplication? I got to multiply by 2. And whatever I do to the bottom, I have to do to the top. So when I rewrite this, I don't have to touch the first one. It's still 5 over 6 minus, now 4 times 2 is 8. 3 times 2 is 6. All right? So now we've got a common denominator. That was our first check. Great. Now the second thing we have to do is write the denominator. Prevent that mistake where we add the denominator. Now we just subtract the numerator. Just subtract the tops. So we've got 5 minus 8. We start at the positive side of the number line. Okay, just put a little fake number line here. 0. These are positive. These are negative. So I'm starting at 8. Over here in the positive, or sorry, I'm starting at 5 over here in the positive. I have to go backwards 8 steps. So if I'm going backwards 8 steps, I'm actually getting into the negative. So 5 minus 8 actually equals -3 over 6. And then we can simplify this, okay, because I can divide 3 out of 6. Okay, so if I divide both of these by 3 at the very end, we're simplifying. Okay, remember, whatever you do to the top, you have to do to the bottom. So -3 divided by 3 turns into -1, and 6 divided by 3 turns into 2. So -3 over 6 is the same as -1 over 2. And you can think about that just, if you forget the negative sign for a second, does 3 over 6 mean the same thing as 1 over 2? Sure it does. 1 over 2 is half. But 3 over 6 is also half. So if you gave somebody 3 out of 6 pieces of chocolate, you gave them half your chocolate. If you give them 1 out of 2 of your pieces of chocolate, you gave them half. So these two numbers mean the same thing and just look a little different. But this is actually the proper answer. All right, next one. -5 over 4, okay, minus a -3 1/5. Well, when I see minus bracket negative, I just turn that into a positive. Okay, plus plus. Okay, so that's really just -5 over 4 plus, okay, plus 3 1/5. Make sure you don't write negative there, right? Because we turned both of those negatives into a positive. Now we're just at the addition questions that we know how to do. First off, we got to change this mixed number. That's times and that's plus. So -5 over 4. Okay, we didn't change that one yet. Plus, okay, start down here. 5 times 3 is 15, plus 1 is 16. And then you always write it over the original denominator, which was 5. Our denominators are not the same. And there is no easy way for me to turn the lower number into the higher number using multiplication. There's no single number I can multiply by 4 to get 5. Okay, so I'm going to have to do it the way I did it before, where I multiply this side by 5, okay, and the other side by 4. So let's just write this out in longhand. This is negative 5 times 5 over 4 times 5 plus, and then let's look at the other side, it's 16 times 4 over 5 times 4. Now our next check needs to be a common denominator. So let's look at it. This is negative 5 times 5 is negative 25. 4 times 5 is 20. Plus 16 times 4, that's 64 over 5 times 4 is 20. There's our check. Common denominator. Yes. Okay, good. So now let's move on to the next step. Let's just write out the denominator so we don't make any mistakes, and let's look at the numerator. Negative 25, and we've got to add 64. So we're starting way down here in the negatives, okay? And then we've got to jump 64 steps into the positive, okay? Now, really, it's just 64 minus 25 is really what it is, okay? Or you could do negative 25 plus 64 on your calculator. You get the same thing. The answer is 39 over 20. Okay, now our next check. Okay, our next check. Is the numerator higher than the denominator? Yes, it is. Okay, 39 is more than 20. So how many times will 20 fit into 39 evenly? We can fit it one time in, but we can't fit it two times in, right? 2 times 20 is 40. That would be too high. So we know we can fit it one time in. Okay, then you write the denominator, and then you figure out how much would be left over. So 20 times 1 is 20. Okay, and how many more jumps did I have to get to 39 from 20? 19. So you can see it's really close to 2. It's 1 and 19 over 20, but it's not quite 2. We can use calculators for decimals. Okay? And I think most people are pretty good with decimals. It was the fractions that typically cause trouble. So we can use a number line or calculator to subtract rational numbers in decimal form. Okay, if we start with negative 2.3 and then we subtract a negative 3.9, the same thing applies with decimals. In my head, I just take those two negative signs and I make them a positive. So I'm left with negative 2.3 plus 3.9. The important part is if you do this step, you can't write negative 3.9. You've changed the question. So like I said, normally I would just take plus, but I don't want to confuse the original question, so I'm just going to put the plus up here. So we start at negative 2.3, and then we have to move positive 3.9. So we're going to move past 0 into the positives. So negative 2.3 plus 3.9 is really the same as 3.9 subtract 2.3, which is going to give us 3.9, that's going to be 1.6, right? So 3.9 minus 2.3 is going to give us 1.6. And it's positive, right? Because we started negative, we made it past the 0, made it all the way into the positives. How much positive? What did I say? 1.6. Okay. If you did it the other way, multiplying out the hidden 1, okay, that would be down here. So I just kind of do this in my head over here. But if you want to do it the other way, it's negative 2.3 minus 1 times negative 3.9. Okay, so you end up with the same thing. Negative 2.3 minus 1 times, negative 1 times negative 3.9. A negative times a negative equals a positive 3.9. You see at this point we're exactly the same as what we had on the other side. You get 1.6. You use whichever method makes the most sense to you. So this is our number line from the previous question. Negative means we go this way, but a negative cancels out and we go the other way. So it really ends up being just plus on that one. We started at negative 2.3, we made it past 0, all the way to 1.6 on our number line. Let's do a word problem just to make sure that we can take sentences and paragraphs and turn them into the proper math. Diver jumps off a cliff that is 14.7 meters above sea level. After hitting the water, he goes down under the water, plunges under the water, 3.8 meters before returning to the surface. Use rational numbers to represent the difference. Remember, the difference is just subtraction, right? In heights from the top of the cliff to the bottom of his dive. Sketch a number line. Okay, I'm going to do two things. I'm going to sketch the actual question, and I'm also going to sketch a number line. So let's just say that this is the water. This is the cliff. There's our dude. Okay? So the diver, it says he, okay, so whatever, it's a dude. It's a guy. A diver jumps off a cliff that is 14.7 meters high. So that's 14.7 right there. And then he hits the water, which is 0. And then he goes down underneath the water, okay, 3.8 meters. So this would be negative 3.8 meters. So the diver jumps off the cliff, goes all the way under the water, and ends up down here somewhere. So we're using rational numbers to represent the difference. The difference. Okay, so this is really just a number line written sideways, written up and down instead of left and right. But let's just write. They asked us to do a number line, so we'll do a number line. Okay, so let's just put the 0 here for now. It doesn't matter where you put the 0 as long as you put the other numbers in the right sort of spot. So let's just say this is 14.7 to the positive because that's above ground, and then let's say down here this is negative 3.8 on the negative side. So the diver starts here, okay, and then dives and then goes past the water and into the water. And it's just this one represented horizontally instead. So there's our number line. Does it actually ask us a question? I moved it a little bit. There we go. Diver jumps off the cliff. Use rational numbers to represent the difference in heights from the top of the cliff to the bottom of his dive. Sketch a number line. Well, I kind of did that already, but they said represent it in. If we're trying to find out, basically what they're asking here, but they haven't asked it in so many words, is here's what we're trying to find out. Find out how far he traveled. Okay. Because we know that it took 14.7 to hit the water, but we also know that he went further under the water. So how far did he go in total is this whole distance, not just the distance till he hit the water. So in total, okay, he started at 14.7, and he's going, that's my daughter, by the way. He's going toward the 0. He's going toward the 0, right? So he hits the water. So if he's going toward the 0, he's going backwards, so he's going negative. But then he goes another couple negatives down to negative 3.8. So down to negative 3.8. And now we've got a question that looks like a lot of the ones that we've done before. And we can do this two ways, right? I like to look at these and just say a negative is a positive. So it's going to be 14.7 plus 3.8. The other way of doing it is 14.7 minus, okay, a negative. So that's minus 1 times negative 3.8. Okay, 14.7, negative 1 times negative 3.8. Negative times a negative equals a positive 3.8. So at this point, we're in the exact same spot, right? So it's 14.7 plus 3.8. That should equal 18.5 meters. Don't forget the units. Okay, and this one, you will get the exact same thing, 18.5. Ooh, pen went a little wonky there. Okay, 18.5 meters. Quick check on my calculator, just to see if I made a mistake. 14.7 plus 3.8 equals 18.5 meters. So they didn't ask this question, find out how far he traveled, but I asked it. So I'm gonna put a sentence here at the bottom. In total, he traveled 18.5 meters. Okay, from the very top of the cliff to the very bottom of his dive in the water, he would have traveled a total of 18.5 meters. Okay, that's 3.3. Again, if you do 3.2 and you understand adding rational numbers, that is adding integers, adding decimals, and adding fractions, you really shouldn't have any problem with subtraction. Just watch your signs, okay? I should put that up here on every page. Watch your signs. Okay, look at those negatives. All right, best of luck. And as always, if you've got any questions, send them to us via email, and we'd be happy to help you out.